Well, welcome back to Base Camp, WNC. I wanted to come out here on the deck and kind of show you the view that when I say we're here just above 4,000 foot line here in western North Carolina, and we are at the top of the mountain. There ain't much above it, maybe a little bit, but not much, but we're way over 4,000 feet. And this is the view, and this is what it looks like from here anyhow. We got a couple peaks and a whole bunch of valleys. But let's get started on this project. Well, here's my spring I'm going to tap for this place. It's flowing pretty good. But as you can see, we're about 3.5 inches. Maybe you can't see. We're about 3.5 inches. And I'm going to try on this one to show you how I scribe this thing. With just figuring it's got to come down about that high, come up about 4 figures, and try to hold my Sharpie on that thing and just kind of sketch it along and see what I come up with. Well, there's my first guesstimation. I'm going to take my Sawzall, cut it off, and we're just going to keep fitting this thing until we can get it down here and go over some of these humps and try to get as close to the rock as we possibly can. Well, there's my first stab at it. You can see I'm still a good inch from there. So I'm gonna have to move this cut a little bit further and come up a little bit higher, especially on the end. Try to get it down a little bit more. Well, there it is. I'm gonna probably about go with that. And as you see from the scrap pile, I got 7 cuts right there right now, just to try to keep marking and snipping and cutting and trying. Okay, we got that thing about fit where I want. And now what we're gonna do, we're gonna take this wire brush and we're gonna scrub in front of and behind of where the dam wall is gonna go. And I don't know if it picks up on the video the amount of mud and moss that's on the rock, but that's all we're trying to do. We're trying to get it, and it's not going to be a real clean surface, but we're going to use hydraulic cement this thing down and in there, and it will stick to the rock, but it sticks a whole lot better to the rock than it does to the dirt and the moss on the rock. And this also helps clean up the spring for the water control. Here it is. I got a bunch mixed up. I got my glove on this time, and I'm going to lay a glob right here where it's going to sit, and then set the dam wall in it and let it harden up. Got to move quick, because like I said, this stuff sets up fast. Well, there it is, right there. Put a glob up here. I left this open to let the water flow. I'm going to set it in, let it harden up, and then we'll go from there. Well, here's the first patch. And it was getting hard when I finally put the camera down and grabbed the dam. But I left that little hole right there so the water can flow. It'll set up. What I'm gonna do now, I gotta go down and get some more cement, make another hole up here with stuff. And I did this on this side of the wall and the other side of the wall. I just smeared it down smooth up against it. I'm gonna go ahead and drill my outlet right there. So when I come back, we mix the next batch up. I'm going to put a big glob here on the outside, one on the inside, and then where it goes in, I've got it tucked behind a rock up here in the bank here, and I'll just keep mixing up and coating the inside and the outside to get it tight. Wanted to show you, just using the plain old bottle, and all I do is go to the stopwatch here on the phone, and we start it and start filling it up, and we count, see how many seconds it takes to fill it up. Well, with just that bottle, it's 16.9 ounces. It takes about 4.58 seconds, about 4.6 seconds, just using 5 seconds to fill the bottle up. That's 12 bottles in a minute. Times 16.9 ounces is 202 ounces. Divide 202 ounces by 128, you come out with 1.58 gallons a minute is what that is coming out of that pipe right now. So that's not bad for that little tiny trickle. Well, there it is. We got the spring all covered up, plastic on it. We're gonna go ahead and fill this in. Thought I'd take a picture of it right quick and show you what it looks like. Well, I had so much fun I forgot to record it, but we dug back into the hill till we hit this great big rock, and I said close enough, leveled it off, and this is where the 305 gallon tank is gonna sit. Now we've got the line run from the spring, and you can kind of see it right there. It's running. Now, it's gonna come in and hook up in this top hole. We got a drain that we're gonna hook up and extend it with that. So if we drain it, it doesn't erode all the soil here. And we're gonna drill a hole and a fitting for the water from the pump going up to the house and the wire coming in, and I'll take you along for them. Well, here's the pump. Once again, it's installed down in the pipe. I don't know if there's the end of it, you can see. And once again, this is probably pump design holder number 4.0. I'm working on 5.0. To keep it from sliding around in the tank and maybe breaking the pipe, I've just bolted pieces of rubber hose on for legs. I've since found a place to buy the little rubber feet like on the bottom of your pressure washer to stick in there. They do fill it full of concrete, so it's got weight on it. And I've gone from using PVC pipe, because where the fitting goes on to it, the thinnest part of the PVC is in the threads of the fitting. And I had a owner grab the pipe trying to pull it and broke it, and we had to go repair the whole thing. So, but this owner's, we're using PEX here for this, and like I said, this is only a 115 volt motor in this thing. Like I said, with their idea of using the solar generator to power it, grid down. So the only other thing I've done now is, according to all the tank manufacturers, the manhole is 16 feet or 16 inches wide. Actually, if you measured, it's only 15. So now these legs on all my new ones are only going to be 14 inches wide, because now I have to go down and take their top off their tank in order to get this thing in without having to wiggle it and fool with it. And it's kind of heavy with the pump, the cement, and everything else. But we got a rope on the back end, a rope on the front end, so you can pull it up on an angle without having to grab the pipe or the wire, and you can lower it in the tank with the cords. Proper way to do it. So I've moved the lid and the ring right here, and it's still just a little bit shy of 16 inches, so at least it's better than 15. Now I'm gonna get the pump and the pipe, set it down in there. So what I have here, and I'll show you when it's done, this end right here will hook into the pump end coming up. It'll go out, and then that fitting right there will be through the tank and then going up to the house. But what I wanted to show you before I put it in here is this little hole. I put a T with a brass plug in it, crimped it down, and what that's gonna do, being we're here at the top of the mountain, there's nothing but rock. The water line, when this thing, like I said, it's not a pressurized system, when it pumps its 200 gallons out and shuts off, all the water can drain back all the way down the hill and come back into the tank through that hole. Yeah, it'll take a little while. but that way the pipe doesn't freeze in the wintertime. And yes, while you're pumping, you got a little bit of water squirting out, but it's not that much. But I wanted to show you this little thing right here before I put it in the tank. Well, we got the tank plumbed up. I'll show you the inside here, but right now, temporarily, this is the spring water just running in. And of course, I'm one bushing shy of the right way to hook it up, so I'm just gonna have to get that bushing. This is the 110 volt electric came in. Got a waterproof box where it's connected, and I'll show you how we run the wire in a pump. And then this is just the overflow that once this tank is full, it'll just keep overflowing. And looking at the sweat line on the tank, it's up to there, right there, which is a little bit better than half. At 1.58 gallons, I think it was like 3 hours and 10-15 minutes to fill it up. So let me show you the inside of the tank and how it ended up. Well, like I said, right there's the water. It's coming up pretty good. But this over here is the line coming up from the pump. We put a union in it right here. So if the pump ever has to be pulled, we can just unscrew this. This is the pump wire, goes into that electric box. We can just disconnect that, grab the ropes, and we can pull the pump up without having to rip out all the plumbing and cut it, and then we can just stick it back in for some reason. Hopefully this thing will be sitting down there for at least 20 years. Well, this is the water line going up to the house and the power line. But from here to the tank, and it's kind of hard to see, I didn't want it to get a bow in it over time, because wintertime, that bow, of course, wouldn't drain, and then it would freeze and break the pipe. So we just ran it inside a piece of rigid pipe. We'll probably tie it up to the tree, all that kind of good stuff. And you just want a constant down angle with that water so that pipe can drain out completely and it don't freeze. Now here's your water coming out at the pump. And it's pumping out of that tank a whole lot faster than it's going back in. Now, in order for it to work, this fitting with the drain has to be above the water level so it can get air in it to back drain back down is the best way to do it. And there it is. It is now draining back that line from this fitting here up to the top of where it goes in the vent. And you'll see it slow down here in a minute. But all it really is a short piece of pipe. I did use a brass plug and drilled a little hole in it. This right here is the highest point where it goes through these poured foundation walls. We cut, they wanted to go right by the vent. We stuck it through there into the room downstairs. But from here, all the way down, all the way to the spring cistern is where all the water will drain back down, completely down the hill, so it doesn't freeze. And this is how it's going to be freeze proof. Called a very simple, it's a drain back system. From this section here goes to the spring. This section here just drains into the tank. Well, this is what I call their water room, because that's all that's in this room. And this was the answer from the person with the water problem, developer or whatever, was originally, that's where the water line came in and then serviced the house. So now they've got a pressure regulator on it. So now what they've done is they add this 500-gallon tank, and it's got a float in it because the water's all the way down to about here. And it fills up with a well whenever it's got water. Then it comes out down here, and this is just 110 volt, 115 volt, whatever it is, variable speed pump. I'll try to catch it when it kicks on. And basically what that's supposed to do is if one person opens a faucet up and then if nobody else opens a faucet up, it keeps speeding up to supply the water to it. But it pulls off of this tank. This is just a drain line if they need to drain the tanks. And then they've got the tanks hooked together here and comes over here and goes in. And so when this tank fills up, it fills these. So that was their answer. And like I said, this owner was blessed that they have a spring on the property doing about 3,000 gallons a day. So we're coming in, or we've come in. This is where it comes into the room. Right here is where it comes in from the outside. And now we're gonna come down here and put our filter UV light. It's gonna fill into this tank and we'll put the float over here. But I wanted to show you this before I got to hacking and doing on this thing. Show you this system. This is what it's originally started out as. Well, here's the finished project where it comes in from outside. I do have to attach this pipe to the wall yet. Comes in through just a plain sediment filter, into the UV light, into the tank. Now all this is controlled by that float switch that's here. And what I've done, this thing's kind of backwards if anybody knows what a sump pump is, because right here is a normal water level in this tank, that tank, and this tank, because the big ball float they have is over here somewhere. So it makes the water level right here. But when the water level comes up to here, this is where the spring pump shuts off. If the well pump's not working and they use this water, which is about 70 gallons in this tank, 70 gallons in the other tank, 70 in this. So then that well pump, the spring pump, will come down to here. This is where the float switch turns it on. And it puts 210 gallons of water in these tanks. And when the float comes up to here, it shuts off at the normal water level. But this is it, as simple as it is. We've just added the spring water to their well water that's marginal at times. So as usual, if it can ever help you out, help you plan something, do something, give you some ideas, it's what we do. My email address is right there at the bottom. Contact me there or through YouTube. And as usual, like it, share, subscribe, tell your friends about it. I'll see you on the next one. Hit the thumbs up and leave me some kind of comment, good or bad.